Okay, the first question is how many valence electrons does a carbon atom have before it bonds? And if I take a look at my handy dandy periodic table, I see that carbon is in the fourth column, and if I count over from the left side, 1, 2, 3, 4, that means that it has 4 valence electrons. So I'm going to go ahead and fill that in. We've got 4 valence electrons. How many valence electrons does a chlorine atom have? Well, let's take a look again at our periodic table here. The periodic table shows that chlorine is in the 7th column, which means if I count left to right, 1, 2, 3, 4, 5, 6, 7, that means that it has 7 valence electrons. I could also kind of gauge that from the -1 that we've got. So this is 7 valence electrons. And then number 3 says, since carbon tetrachloride is made up of 1 carbon and 4 chlorine atoms, how many total valence electrons? Well, we've got C, which has 4, plus 4Cl, which each have 7, means that we've got a total of 32 valence electrons. And if I take a look, I'm just going to go ahead and say that I verified that. If I look back up here, oh yeah, we got 2, 4, 6, 8, and then 6 times 4 is 24. 24 and 8 is definitely 32. So I'm going to go ahead and say yep. Find the sum of the valence electrons for NF3. Well, N, using the periodic table, has 5 valence electrons, and each F has 7 valence electrons. So that would be a total of 21 valence electrons, plus the 5 gave us 26 valence electrons. And if I go back up here and I count, 2, 4, 6, 8. 6 times 3 is 18. That comes out to be a total of 26 valence electrons. Number 7 says, in CCl4, carbon is the central atom. In NF3, nitrogen is the central atom. What is meant by the central atom? It's the one in the center of the molecule. In SF4, sulfur is the central atom. You can tell which atom is the central atom simply by looking at the formula. How does the formula give away? It's the one with the least amount of atoms. Central atom here, then. I'm just going to circle them if I can. Carbon, phosphorus, silicon. Okay, for each of the compounds from question 9, add up how many valence electrons should be in the bonding picture. So phosphorus, let's make this a little, wrong one made bigger. Make this a little bigger. Phosphorus is in the 5th column, which means we've got 5 plus 3 times 1 is 8 valence electrons. Silicon is in the 4th column, plus 2 times 6 will give me 16 valence electrons. Okay, the next question says that CO3 is 22 and CO3 minus 2 is 24. Then it says, where do we get those 2 extra electrons? Well, we got them from probably a metal, right? So there had to be a transfer of valence electrons, and those went to the CO3 minus 2. NH4 is 9, and NH4 plus is 8. So NH4 acted as a metal and gave away electrons. For a negative charge on a polyatomic, we must add, and for a positive charge, we're going to subtract. For each of the polyatomic or ions or molecules, determine the number of valence electrons. 5 plus 3 times 6 plus 1 is 24. 6 plus 7 times 4 is 34. And H3O plus, we're going to go 1 plus 1 times 3 plus 6 minus 1. That is 3 plus 6. That's 8 valence electrons. Phosphorus is in the 5th column, plus 4 times 6, plus an extra 3 electrons to do the negative 3. We've got 29, 32 valence electrons for PO4 minus 3. Okay, and then number 15 says, write the Lewis structure for nitrate, NO3 minus 1. Okay, so we're going to just first make our counting here. So we've got N that has 5 valence electrons, and we've got O that has 6 valence electrons. So we'll do 1 times 5 plus 3 times 6 plus an extra 1 because of the negative 1. And that comes out to be 19 plus 5 is 24 total valence electrons that we can show in the picture. N is central because there's only one of them. I'm going to try it all with single bonds. When I do that, my N needs an extra set of electrons on it. And each oxygen needs another 6. I'm going to put a negative 1 on the outside. And then let's go ahead and count those up. That is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So that does not work. So if that one doesn't work, let's just try it another way. So I'm just going to white that out. And then this time, since we had too many electrons, we're going to try it with a double bond to one of those O's. So now this N, when I look at it, has 2, 4, 6, 8 electrons. And each O needs 6. So I'll put those dots around. Okay, so now if I count them up, let's count them up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Ooh, I made a mistake. Sorry about that. Let's start this one over again. If I were real fancy, I might edit this, but so let's do this again. N, single bond O, double bond O, single bond O. This needs 6. This needs 6. But this oxygen, 2, 4, it only needs a pair. I overloaded that other oxygen. So now let's count them up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And that matches my 24 up here, so now we're in good shape. Okay, good. Let's go ahead and make SO2 then. So first things, S is 6 and 2 O's. That'll be 12. That's a total of 18 valence electrons. So let's go ahead. We got an S as our center. Single, single. I'm going to add the electrons to make 8 around each one. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Uh-oh, I only got 18. So now we try it again. Oops. Let's try it again. Here we go. S. This time we'll do a double bond to an O. Single bond. This one still needs 6 more. This one only needs 2 more, though, because we've got 2, 4, 6, and we just need 1 more to make 8. And this last one needs 4 more because we've got 2, 4, 6, 8. So now let's count up the number of electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 18. Looks good for SO2.